equalize, or do we need to have you send?
Yeah, I think so.
Okay.
Let me open it.
Okay.
Alex. Canvas. I'm studying for my final.
Huh. Okay. Now, you're a senior in high school, is that right?
Yeah.
Okay. Just taking college algebra. Okay.
Right. Yeah.
Do you know where you're going to college yet?
Yeah, I'm going to FAU.
Cool.
Yeah.
FAU is where? That's...
Florida Atlantic.
I know. Where's it located?
Oh, it's in Boca. They have a few campuses. There's one in Jupiter and one in Fort Lauderdale, but the main is in Boca.
That'll be nice. Nice, close to home. You live in Boca, don't you?
Yeah, I do. Okay, so practice test, final exam 1. All right, so I guess we should just like go through all the questions and make sure I get how to do them. You know, from the practice.
I'll let you totally direct, because
okay.
You know how well you know certain problems and how well you don't, and we don't need to cover the ones you know well. So.
Right. All right, so this one is in parentheses, -3 a to the 5th, b to the -2nd, close parentheses, all squared.
Okay. There's a rule of exponents. We'll talk about that. If I say some number to the x in parentheses raised to the y, that's always, you multiply the exponents.
Right.
That's what we're going to do here. Okay? Everything in the parentheses is being squared. So everything is, this 2 here is acting on every single thing. So we have to square the -3. And let's just do it term by term.
Okay.
Okay? So what's -3 squared?
9.
Okay. What's a to the 5th squared?
10. A10. A to the 10th.
A to the 10th. And what's b to the -2 squared?
B to the -4th.
Okay. Now, typically, they want your answers to not have any negative exponents in them.
Right. So you turn it into a fraction?
Well, you put this negative exponent, you just put it on the other side of the fraction bar. In other words, it becomes b to the 4th. Like that.
Okay.
That's what a negative exponent means. In case you have any questions at all, 3 to the -4th is equal to 1 over 3 to the +4th. And this negative exponent works both ways. Not only can you move it from the numerator to the denominator, but you can actually go the other way. Let's say I had 2 over 3 to the -4th. Well, I can take this 3 to the -4th and move it to the numerator. So that equals to 2 times 3 to the 4th.
Okay.
So, yeah, you can, let me close my door so my dog won't annoy us. So that's the deal with negative exponents. They just mean reciprocal. They do not have anything to do with negative numbers. That's a concept that a lot of people have a lot of trouble with. They immediately want to make it a negative number. And it never is, notice.
Right, it's just...
I suppose if it was a negative number to an odd exponent, then it might be a negative number. In other words, if I had -3 to the -1, well then that would be the same as 1 over -3, so that would be a negative number. But generally, they're positive numbers.
Usually, yeah.
All right, what else you got?
All right, so the 5th root of a squared.
That's it?
Yeah, it says write it as an exponential expression.
Right, okay. Radical signs are really much better handled using fractional exponents, where the denominator of the exponent is the root and the numerator is the power. So this is a true statement.
Is that it?
And that's all you do. In other words, if I had the sixth root of a squared, it would be a to the 2/6, which reduces to a to the 1/3, but nonetheless, that's all you do. And when you get into any kind of forms of higher math, exponents work a lot better than radical signs do.
Okay.
Especially with calculus. So much of calculus starts with the exponent. And so if you have radical signs, your first step is to convert them all to exponents before you
Okay.
proceed. All right, what else?
This one says, the diameter of Pluto at its equator is approximately 2.39 times 10 to the third kilometers. Write this in, oh, I can do this. This is just scientific notation.
Oh, okay.
That's easy.
Mm-hmm.
I'll skip that. All right, so this is the square root of 20 t to the 8 w to the 5th.
Okay. The way you want to do these is term by term. We're going to start with the square root of 20, then we're going to take the square root of t to the 8th, then we're taking the square root of w to the 5th. Okay. Now, let's talk about something. If I had this, what's that going to be equal to?
X times the square root of x.
Correct. In other words, I could write that as x squared times the square root of x. And then that becomes x. So you end up with that. Well, we're going to end up treating that w to the 5th in a similar manner. Hold on. One thing I hate about this program is you don't know when you're in erase mode, and if you touch anything, it all disappears. So we'll start with the square root of 20, and then we'll worry about simplifying that a little bit later.
Okay.
What's the square root of t to the 8th?
T to the 4th.
Okay. So here's our problem. In other words, I've immediately separated into the square root of each of these things.
Okay.
Now, this is 4 times 5, so that's 2 root 5. You correctly said that was t to the 4th. What's the square root of w to the 5th?
W to the 2nd times w.
Times the square root of w.
Right.
Okay. And now we want to put all that together. So these three terms go out in front. 2t to the 4th, w to the 2nd. We're only going to have one radical sign, and inside there is 5w.
Okay.
Okay?
Yeah, that makes sense. T to the 4th, w.
I erased that too soon, holler. I'll leave it up there a little bit longer.
No, I wrote it down. That's okay.
All right. And I do, if you remember, I record all of these. So if you wanted to review this session, it'll be up there by this afternoon.
Okay, cool. Okay, this is factor by grouping, and I'm not good at that, so let's work on this one. So it's VW.
VW?
V times W plus 3 times W minus 2V minus 6.
First of all, before you can group, the coefficient of that term divided by that term has to be the same ratio as this coefficient divided by that coefficient. And in this case they are. This one is 1/3, this one is 1/3. So that's the first thing to recognize. What's that?
Why does it have to be that way?
That's the only way you can group and make it work.
Okay.
So it's a particularly good way of handling cubic functions. Now this isn't a cubic, but it's going to demonstrate the grouping nonetheless. What I'm going to do is group that, like that, and then I'm going to group this. But notice that if I merely add parentheses, I'm changing it. So I'm going to rewrite it. What goes in the parentheses such that I have not changed the expression?
2v plus 6.
Correct. That's a vital step right there. And that's the easiest place to make a mistake. And that's the place everybody makes their mistakes.
Okay.
Now, factor out what you can from the left expression.
I'm sorry, what did you say?
Factor out the greatest common factor from the left parentheses.
W.
Leaving.
V plus 3.
Factor out the greatest common factor from the right parentheses.
2.
Leaving.
V plus 3.
The only way grouping ever works is if that's the same as that. So if you're trying to solve something by grouping and you get a V plus 3 here and a V minus 3 over there, probably means you made a mistake and made that easy mistake to make.
Okay.
So it's a flag. You should go back and check your arithmetic. Now, at this point, we do something rather unusual, and that is we take a greatest common factor out that's not a monomial term. It's a binomial term. Note that there's a greatest common factor. It's that right there. So I can factor it out. V plus 3 in parentheses. And what's left over? W minus 2. So that's how you factor by grouping. And it works particularly well when you're trying to solve cubics. I'm surprised they didn't give you it as a cubic. Let's talk about that. And let's see, that's a squared. This would have to be, what was the other? 2x minus 6. Let's say our goal was to solve this polynomial. Have you had cubic polynomials yet?
Yeah, we've had a few.
I was going to say, you must be on the verge, because that's the only place you use grouping.
Okay.
Okay. If I wanted to solve this, there is no quadratic formula for cubics. So cubics are a bear to solve. They frequently are 20-minute problems, unless they lend themselves to grouping. In other words, if you can group it, then it's easy to solve. And again, what I'm looking for is the ratio of the coefficients of the x cubed and the x squared term to be the same as the ratio of the other two coefficients.
Does it have to be 1/3?
They don't have to be 1/3. They have to be equal to one another.
Okay.
They could be 4. I could make that a 4, make that an 8, and now they're both equal to 1/4.
Okay.
Okay, but just because I messed it up a little bit by that scribbling, let me go back to the original. Okay, now I'm going to do the same thing. I'm going to put parentheses around those, and those parentheses never do anything. They're not really necessary except for understanding.
Okay.
But the second set of parentheses is really important, that when you add them, you change that sign right there.
Right.
Now, greatest common factor comes out, x squared. What's left? X plus 3. Over here, greatest common factor is 2. What's left is x plus 3. Factor out the x plus 3, and now you have the solutions. Almost.
Okay.
Almost. Not quite done, because I can factor this. So it becomes x plus 3. And let's talk about factoring that. You've learned difference of perfect squares, right?
I've touched on a bit. It's definitely one of the things I need help with.
Well, difference of perfect squares means this. If I have a squared minus b squared, it always factors into a minus b times a plus b.
I do know that. I thought you were talking about, what's it called, factoring by forming the perfect square.
Okay, that's a little different. Yeah, by completing.
Completing the square, yeah.
Right. So difference of perfect squares, I'm not sure why it's called that because they don't need to be perfect squares. This is not difference of perfect squares, but nonetheless it still factors into x minus square root of 2 times x plus square root of 2, which is important in this problem because I'm looking for the zeros. So where are my 3 zeros?
At a square root of 2, negative square root of 2, and 3.
Correct.
Negative 3.
Correct. And so this treating that like it was the difference of perfect squares makes it easy to factor. It's x minus square root of 2 times x plus square root of 2. So difference of squares is really what it should be called. I can take the difference of anything. If I have x minus 7, guess what? That factors into square root of x minus square root of 7 times square root of x plus square root of 7. Multiply these two together, you'll get that. So
it doesn't have to be perfect.
No, it doesn't have to be perfect. Doesn't even have to be squares. In other words, the solution is always the square root of a, whatever that term is, minus the square root of that term, times conjugate. But I digress. I want to stay focused on what problems you need to deal with. Although that definitely was, no, that was one I made up. So, okay, let's get back to your problem.
So I'm not the best with factoring offhand. So this is a factoring problem.
Let's do it.
10z squared plus 9z plus 2.
Now, there's two types of factoring problems. I call them elementary and difficult.
Okay.
The elementary factoring problems are the ones where this coefficient is 1. Problems like this. Okay? These are elementary factoring problems. I can give you 3 steps that'll solve that every single time.
Okay. Well, I'd like to hear them.
And we'll go through those. I think it's important. But when you get to the difficult factoring problems, the reason it's difficult is it kind of becomes a trial and error process, which factoring pretty much is in the first place. It's just that with the easy ones, it's not really trial and error. I can give you 3 rules and they're going to work on every one of them. The first step I got to do is break up the 10z squared. Okay?
Mm-hmm.
And I can break that up into 5z and 2z, but I could also break it up into 10z and 1z. And what I generally recommend with people with any kind of factoring is always start with your 2 factors that are closest together. Well, 5 and 2 are certainly closer together than 10 and 1.
Right.
I'm going to begin there and see what happens. Now, what are both signs? That's the next step.
Positive.
Correct. Both of them have to be positive. So I can produce a positive 2 there and a positive 9 there. And there's not very many factors for 2. It's 2 and 1. So either it's 1 and 2, and notice that does not produce 9z in the middle. The way you tell, and this is an important part of the solution, is figure out what the inside and the outside is. There's the 2 insides multiplied together, the 2 outsides, and then add them together, and that needs to be your middle term. Well, in this case, it's not. So
Right.
let's go and try 2 and 1 instead of 1 and 2. Now, does that produce the proper middle term?
You have 4z, and then you have 5z. So yeah, that.
There's your answer. And that's the way you do it. And the more difficult the quadratic, the tougher the factoring is. In other words, make that a 12 instead of a 2. And now I have tons of combinations because 12 factors into 6 and 2, 12 and 1, and 4 and 3. So the more ways that these numbers can factor, the more complicated is the problem because it's a trial and error problem. So you just have to keep trying different combinations until you produce this term. So that's why this, what I kind of call the double smiley face method, is not just a method for checking elementary factoring. It's actually an integral part of the process of figuring out how to factor harder ones, like this.
Okay.
Okay, but that's, do you have any more?
Not factoring, but can you show me the 3 steps?
Yeah, I'm going to show you the 3 steps. Here we go. And this applies pretty much whenever you just have x squared. First thing, there's only one way to separate that. Step 1.
Right.
Step 2, figure out both signs. What are both signs?
One's negative and one's positive.
No, they're both negative. Remember, what you're doing here is foiling in reverse. Do you know what I mean by foiling?
Yeah. First inner, outer, last.
Right. Well, the last is multiplying that number by that number and producing that number.
Okay.
So when you see a plus sign in front of the 10, you know the signs have to be the same. You can't produce a plus sign if they're opposite. If one was positive and one was negative, that would be negative all the time.
Okay.
So the fact that that's positive means the signs have to be the same. And to figure out whether they're minus minus or plus plus, look to the middle term. Since the middle term is negative, they're minus minus.
Okay.
That's step 2. And step 2 is definitely figuring out both signs, not just one. A lot of people try to do factoring completely in their head. They try to do all 3 steps in one. And I do not recommend that. The third step, factors of 10 that add because of that plus sign to the number 7. Not to minus 7, but to the number 7. Well, what factors of 10 add to 7?
Factors of 10 add to 7? 5 and 2.
And it doesn't matter which one I put where. Okay? Now, that's the easiest kind of factoring problem. There are only 3 steps. I'm going to make it one step more difficult by putting a minus sign in front of the 10. Now there's 4 steps. First step, split up the x's. Second step, determine the signs. In this case, they're both opposite. And it doesn't matter whether I make it plus minus or minus plus, as long as I'm dealing with x's that have the same coefficient in front of them.
Okay.
Okay, so I've done step 1 and 2. Now, step 3 is factors of 10 that subtract to the number 3. Well, again, it's 5 and 2, but now I have to figure out which side the 5 goes on and which side the 2 goes on.
Well, the 3 is negative, so the bigger number would be...
The bigger number goes with the sign of the middle. That's the 4th rule. So Elementary quadratics can be factored in either 3 steps if that's a plus, or 4 steps if it's a minus. There's not a lot of trial and error involved. I suppose if that was an 8, then I would have a little bit of trial and error. Now I want factors, excuse me, if that was a 9, now I would want, no, it's not, there's no trial and error. Now I would want factors of 10 that subtract to 9, excuse me. Am I confusing you yet? In other words, factors of 10 that subtract to 9, well, that's clearly 10 and 1. And so the 10 goes there, the 1 goes there.
Okay.
So elementary quadratics, I've just given you everything I know, and it'll work on every single one you come across. Now,
Okay.
if you come across a quadratic that does not factor, then what do you do? In other words, let's make this, I had 7x plus 10, let's make it 11. Now, I'm not going to be able to factor this. In other words, I am not going to be able to find factors of 11 that add to the number 7. They don't exist. So what's the alternative now?
I don't know.
Quadratic formula. If you don't have this memorized, you want to memorize it. You definitely are going to need it for college algebra. Now, for the quadratic that I've written, what is A, B, and C?
A is 1.
B is,
B is -7.
and C is,
C is 11.
okay. So if I want to solve this, in other words, if this was an equation and I want to solve it, I want to figure out where the zeros are, then it's minus B, which is plus 7, plus or minus the square root of 49 minus 7 squared, minus 4AC. Well, that's 44, all divided by 2. And that answer is 7 plus or minus the square root of 5 divided by 2. And there are your 2 zeros for that function. And just so there's no misunderstanding, you know what this plus or minus means, right?
Right. Plus the square root of 5 or minus it. It's 2 separate zeros.
2 separate answers. In one case you use the plus, in the other case you use the minus.
Right.
Now, if this number here is negative, in other words, if that was a -5, then I only have 2 imaginary solutions, 2 complex solutions. And they do not cross the x-axis, so there are really no zeros. In other words, if I had a quadratic that was a parabola like that, I can tell instantly that looking at it that it doesn't cross the x-axis, so there are no zeros, which means must have imaginary solutions. And imaginary solutions always come in pairs. They never come alone.
Okay.
So this would be 7 plus root 5I over 2 and 7 minus root 5I all over 2.
Why would imaginary solutions help you in any way?
That's an excellent question. I spent many, many years of my life trying to figure out why there were such things as imaginary numbers, because they are imaginary. They're not real.
Right.
They come into play in higher mathematics in a big way, really big way. In fact, one of the, you're familiar with E equals MC squared.
Right.
The mathematical equivalent of that is e to the I pi plus 1 equals 0. And this is called the most famous equation in the history of math, and the most beautiful one. for one thing, it relates the 5 most important numbers in math in a beautifully concise, unbelievable way. First of all, E has very little to do with pi, right?
Okay, yeah.
I don't know if you know the definition of E, but it's a limit problem. It's approximately 2.71. Has to do with exponential growth and stuff like that.
The natural logarithm, isn't it?
Exactly, yes. And pi is merely the circumference of a circle divided by its diameter. So the fact that E and pi would be related in this weird way is really amazing. And the fact that E to the I pi is equal to precisely -1 is truly amazing. This was derived by Leonard Euler. And like I said, they did a survey of professional mathematicians, and this is the most famous equation in math. That's kind of the equivalent in math to E equals mc squared in physics. Maybe not quite as many repercussions, but in other words, E equals mc squared led to the nuclear bomb. I'm not sure that Euler's equation.
What is the Euler's equation?
What does it help you? Might lead to time travel or something. Who knows?
What does it solve?
Well, imaginary numbers actually come into the most important unsolved math problem in history, which is called Riemann's hypothesis. They've been trying to solve Riemann's hypothesis for 200 years or 150 years. Did you ever see the movie Beautiful Mind?
No, I didn't.
It's about the mathematician John Nash. He actually becomes schizophrenic, and the reason is he was trying to solve Riemann's hypothesis.
Okay.
2 of the greatest mathematicians in the early 20th century spent 20 years trying to solve it. They both went crazy. It's a difficult problem to solve, and they say that if anybody ever solves it, it will be almost the equivalent of solving for the theory of everything. In other words, blending relativity and quantum mechanics together.
Okay.
If they can solve Riemann's hypothesis involving imaginary numbers, they might just discover the total theory of the entire universe, and they would know it all.
Wow.
So
that's an intense formula.
That's how important it is, yeah. Whether they'll ever solve it or not, I don't know. Every century they put out a list of problems to be solved in the next 100 years. And that problem was on the 1900 list, and nobody solved it. And it was also on the 2000 list, along with 19 other problems. And of the 20 problems, 16 have been solved, but 4 still remain unsolved, and Riemann's hypothesis is one of them.
Wow.
Yeah, it's an interesting story, actually, the history of it. But enough. Sorry, I didn't mean to waste your time on other stuff, but
no, it's okay. So we paid for the full hour, so can we use that later in the week?
Absolutely. Absolutely.
Okay.
Anytime you have a credit, you know that you can use it.
All right, awesome. So I'll schedule you again this week. I want to have my finals on Saturday.
Okay.
And I'm going to work on some of the stuff on my own, but when I get to, I'll save the complicated problems for you.
Okay, hold on. Before you go, that's what my schedule looks like. So beware. Get your appointment in there quick. In other words, at this, unless you can do it early in the morning like today, and then I'm open all week, and there was no problem. But,
yeah, on Thursday I can do that.
Okay.
And on Wednesday I can do that.
That's your best bet.
Okay.
Because this spot here on Wednesday is going to get taken real quick, and then I won't have very many evening spots for the week.
Okay.
And
yeah, so I'll get
it'll be like that for until finals. In other words, until the end of May.
Yeah.
So book early.
All right, I will.
And I certainly appreciate that payment.
Yeah, I'm sorry about that.
No problem. It's not your fault at all. I always feel a little bit bad for the student when the parents don't pay that bill. So, but
All right.
okay, I'll talk to you later this week, Max.
All right. I'll see you. I'll talk to you soon.
All right, bye-bye.
Bye.